Hey, party people. It's a beautiful day to do some speed testing. Let's go. Today we're going to be looking at Battle of the Bandwidth, which is a speed test tracker I built over the past few weekends. And my motivation was because we just moved into this new house that was wired for Cat 5, but for a phone, not internet. So I had to rewire it. And I wanted something that I could track the speed as I made changes to the infrastructure. So hopefully I didn't kill it, take it down to 10 megabit per second. It's wired for 2.5 gigabit and it's working pretty good. So hopefully it works for you as well. The other self-hosted options out there, I felt like didn't quite fit the need for me, especially using iPerf 3 as a provider is huge for internal networking. But also the last one I looked at used Ookla as a speed test provider, and their licensing is a little fuzzy for me. So didn't want to have to deal with that, or something you can use in your company in a commercial setting. So hopefully it'll be something that interests you and you can put to use. So we're going to walk through the app specifically, what it does. It's pretty simple, so it won't take too long, and then we'll look at setting it up and getting it running. So stick around and let's nerd out. All right, so here is the Battle of the Bandwidth application. I'm just going to scroll through real quick so you can see what it actually looks like before I do a little feature walkthrough. So up here we've got filters, so you can just filter it down by date range. It's got a little date picker for you, start and end date. We've got server selection. So if you had multiple iPerf 3 servers, or if Libre Speed pick different servers for you, you'll see them here. So you can limit it down even further from a provider. And the Libre Speed provider, they will automatically pick what they think is the best server for your client. So you may see multiple clients end up here, or multiple servers end up here. So I've seen Virginia for some reason pop up here because Libre Speed thought that was the best server, even though it may not have been. It might have been at the time. As you're dealing with these providers, they end up with their own bandwidth restrictions or multiple people querying them at the same time. So obviously they have their own limited bandwidth, and you'll see that reflected in your speed results here. That's why iPerf 3 can be especially helpful if you can verify your internal network is at least up to your expected speed. You can check multiple places that your external speed is what you're expecting. But this kind of gives you a good average. So here we've got max data points as well, so you can put any number in here you want. We can take it down to 1, 2, whatever you want. This is a relatively new instance, so we've only got a few data points. As well, there's a time display, so the default is UTC. You can see down here, this says 23Z for Zulu, so that's UTC time. I'm here in Fort Collins, Colorado, so local time will be Mountain Time, so you can see that's 1700. And let's see, I'll show you these provider functions as well. They've just got a little React hook on them to update as you select. Now, if you select incompatible servers and providers, obviously you're not going to get any results. Cloudflare only has one server. That's all they advertise, so that's all you'll ever get from there. But functionally, these are the same because I only have one server for each provider right now. And then we've got some statistics here. Download speed, upload speed, ping, average is this big number, and then max and minimum below. So max is really helpful just to make sure your hardware can actually do this speed, and average is usually what you're getting when you connect to the external services. Down here below, we've got the scheduled test, which is the heart of this application. So we've got an add schedule button, which you can go in, set a name, so monthly speed tests. It uses cron expressions, so if you're not familiar with those, you can click this show helper and it will kind of help talk you through whatever you're trying to do. So, if we put 11 in here, it'll say 11 a.m. We could put 2300, it'll say 11 p.m. You can do things like every 5 minutes. It'll kind of help guide you through this as you set it up. There's obviously tools out there. If you just search for, like cron scheduler helper, I'm sure you'll come up with a lot of options. Additionally, for iPerf 3, you'll see it shows these host endpoints. That's where you can put in a domain name or your internal IP address for your iPerf 3 server, and then the port. So 5201 is the iPerf 3 server's default host port. And then we've got some public iPerf 3 servers here. If you go to this webpage, it'll show you some possible ones you can connect to. And so you'll just drop their data into there, their server domain name over here, and then their ports over here. This one's kind of nice. It's got 100 gigabit, but it's in France. So unless you're in France, it might be a little iffy or around there. All right, let's, if I cancel out of this one, we can scroll back down, look at the individual row functions. So run now will schedule that speed test to start for you, and we'll refresh here in a minute. I'll show that shows up. The name, the cron schedule, your provider, host info. That's only for iPerf 3 really. You can activate or deactivate it. So if it's set as inactive, it will not run, but it's nice to have it there in case you need to start it up. Say you're changing around your network, you can have something that runs every 5 minutes or every minute, just to make sure you're not blowing up your configuration. And then the edit page will allow you to delete or update the schedule as you needed. So overall, pretty simple application, just on the user side. All right, so next we'll walk through how to get this set up, what that actually looks like, using Docker Compose if you haven't used that before, and some of those technical details to actually get this set up and running on your own server. All right, so let's look how to set up the Battle of the Bandwidth application. Let's pull open the GitHub repository. So if you go to this link, github.com/philipshreve/Battle of the Bandwidth, you should reach this page. There are two ways documented here. You can just pull down the Docker Compose file, or you can build the images yourself. So either way, if we want to do this pre-build images way, you can, make a directory, call it, whatever you want. Change in that directory, create a Docker Compose.yaml file, and then copy this file. Straight into that. And you don't need to change anything here unless you want to change the exposed port where you would access the web interface on. And that would be this one where it says 40,080. You can go ahead and change that to whatever you want it to be. Otherwise, you don't really need to change anything in here. The other thing it talks about is time zones. You can add a .env file that contains these variable names. So for example, if I wanted to, have the server running in my local time zone, we can look up America/Denver. You can look up your individual one. Let's save this YAML file, create a .env file, paste that in there, and then you can simply update those values. Save that. That's the only two files you need in there. Then go ahead and type in Docker Compose up -d. You may need sudo for that, depending on your system. It'll pull those images down. I have them built on Docker Hub for a couple different architectures, so hopefully it works for you. If not, you can go ahead and build them for your system. We'll let that go ahead and download. And this is the status you should see at the end if it was able to pull them successfully and get them started. If you are unable to get those started, the alternative is that you can build those yourself. So just copy and paste these commands in. You'll clone the repository, and so you just pop those in there. It'll pull down everything. That's actually going to put it in a different directory, so you'll need to go into there and then do docker compose up -d --build, and that will trigger it to actually build for your system. And hopefully that works for you. If not, I'm not sure that I can provide much support there. I might be able to provide some help. Just shoot me a message and I'll try to help you out. I can't guarantee anything though. Otherwise, it should be running for you after that on port 40,080 or whatever your custom port is, and you should be able to pull it up just fine. So good luck to you. Next, we'll walk through some of the internal implementation details. I'd love to talk about just some of the architecture, maybe design decisions I made, runtime decisions, why I chose Go, why I chose Node, some of those sort of technical details. So if you want to nerd out with me, stay tuned. I'll pop into that next. So if we look at the code for this application, we can dive in a little deeper on some of these technical decisions I've made. This README, goes pretty well into just the structure of things at a high level, React front end, Go back end, Node back end, and a Postgres database. But it doesn't go into the why of those decisions. So I'd love to just dive into that a little bit now and discuss that. The heart of it all is a Go application, and Go is great because it is just extremely efficient, simple. I love it just because it's statically typed and it makes development so quick. There's a few interesting pieces to this service. Of course, we have our main Go file here. That's just, establishing a connection to the database, runs any migrations, and then loads the cron jobs. So what might interest you about this is that it's using a few CLI programs to actually make these speed tests happen. So if we look at these speed tests individually, this Libre speed test here, it runs the Libre speed CLI with a JSON flag to output JSON, parses that, stores it in the database. Go makes these kind of things so easy. So Cloudflare speed test, this actually makes a call to the Node backend. That is why, the only reason why we have the Node backend is because the Cloudflare service uses the Cloudflare published API library, and it makes it super easy to perform speed tests with their system. So that's why we have this Node backend, is simply for these Cloudflare speed tests. It does nothing else. The iperf3 speed test, it simply orchestrates that iperf3 command for you with your designated host. And then to get latency, it does a ping command and then parses that out and stores that. So that's really the heart of things of the speed test. How it runs the speed test is it calls CLI commands and then makes a call out to a separate backend service to use a Node library. And then the other major part is the cron jobs. So scheduling things is difficult. Cron makes them a little easier with some compromises, such as, not guaranteed point of second execution, but best effort execution, which is really great for something like this. And so we use a cron job package to establish this, and it parses them, it builds the cron job file, and then it reloads the cron service just to make sure everything runs on time. And that's how the schedule tasks work. The front end is a React application. It uses the Next.js framework. We really don't take a lot advantage of a lot of features there. Again, it's just such a simple application, but very handy. I'm not a front end expert, so I'm sure if you look through this code, you'll see some things that could be optimized, but it works well enough for this application. And there's some structure to help you kind of understand what is actually happening. You've got a little backend for front end architecture here and a simple schedules page with create or update action. And then our main page, chart components, filters, pagination, all that good stuff here. So this is where I've found LLMs to be especially helpful, is to fill in my gaps here on the front end, especially styling. I love Tailwind. It's what I use in my day job. It makes styling super simple. So the LLM can kind of just automate a lot of that for me, make things look nice, mobile responsive. But again, it's not super complicated application. So you would kind of expect that from something like an LLM. So overall, super simple. We've got our Docker files in here. Let's look at this Docker Compose file a little more. Nothing too fancy in here. We've got our published image directory namespace. Pull policy only if it's missing. Our context is in that front end directory. And XBake provides for multi-platform builds. Let's see, the end file is the time zone information. That's where the Go backend service can be reached at, expose that port. And we do some health checks here before we start up the service. The Go backend service is very similar. Second verse, same as the first. Provide a little more environment variables for the database connection, as well as that node server for the Cloudflare service. And the node server really doesn't do much either, pretty simple. The Postgres database is also hosted here. It's got a mounted volume, so just make sure you don't lose that. It's got a little health check test here just to make sure it's healthy before we start anything else. That's been crucial, I found, just to make the orchestration really simple as people are pulling this down to their server and starting it up. It just makes it very streamlined and easy. So that's the overview of the Battle of the Bandwidth application. Some of my design decisions I've made, Go is great, simple, easy for a backend, especially when you're calling command line CLI, command line interfaces. Node is great for external libraries you need to connect to. It's very popular, so there's a lot of packages out there. And then, of course, for the front end, we're using React just because it's ubiquitous and so many people understand it now. And that's what I use in my day job. So what else is interesting? The backend node service uses the Nest.js framework. That's what I use in my day job. It's similar to Angular if you've used that sort of structure. Because it's such a simple application, we're just calling out to Cloudflare. We don't have any tests set up. The structure's in there in case we want to do them. The SQL migrations are pretty simple. It is just using a serial increment, so it will run through these. As far as it'll say what version am I on. So initially we create this metadata table with a big int, and we just increment that every time we run this. So on startup, it runs this first SQL script to set up that table, and then we set up all of our other tables, and then we add the providers. And essentially, as this app continues to grow, we just keep adding files here, 4 underscore, whatever the new feature is, 5 underscore, 6 underscore, etc. And that kind of provides for easy migrations, no matter how far behind you are, so that the user doesn't have to do anything manual for the most part. Of course, there are huge breaking changes that can happen, but hopefully this mitigates the user having to do any manual sort of updates. All right, I think that's it for the technical walkthrough of Battle of the Bandwidth. Go ahead and give it a try. Let me know if there's any changes you want to make with the pull request, anything like that. I'm interested in growing it. If you think it's helpful, let me know. And this is just one way I'd love to give back to the open source community in a small way. So thank you all for your contributions as well.